Hi, we are participating in Texas Instruments India Analog Design Contest 2012-13. Our team number is 61.3. We are currently pursuing our BE in Electronics Engineering from Sardar Patel Institute of Technology, Mumbai. Currently the contest is in its phase 1A, wherein every team has been given a problem statement. Our problem statement is as follows. The problem statement is, we have to implement a Taub-Thomas bi-quad filter using TL082 op-amp IC from Texas Instruments. The first part of the problem statement is to implement Taub-Thomas low-pass filter. It consists of 3 stages. All the 3 stages are in inverting configurations. The first stage is an practical integrator. The second stage is an ideal integrator. And the third stage is a summing amplifier. The input to the circuit is given as a sine wave of peak to peak 2 volts to the inverting terminal of the third stage. The entire setup is implemented on the analog starter kit provided by Texas Instruments India. As per the requirement, we have used type 1.1, type 1.2 and type 1.3 op-amps which are in the inverting configuration. We implemented the circuit using the kit and found out that the cutoff frequency was 200 Hz, which was verified by simulation. The second part of the problem statement is to implement a voltage control Taub-Thomas bi-quad filter. This is implemented using a multiplier block at the output of the first stage. The multiplier IC is MPY634KP provided by Texas Instruments. The input to the multiplier IC is the output of the first stage, and the second input is a control voltage of 1 volt, 5 volt or 8 volts. The output of the multiplier is equal to the product of the 2 inputs divided by the reference voltage, which is considered as 10 volts. This is according to the Analog Systems Lab Manual. Now you can see the actual implementation of the circuit. We have taken VC is equal to 5 volts. We have used a function generator of 1 MHz to provide a sine wave of peak to peak 2 volts. There are 2 DC power supplies. One is used to give voltage control of 5 volts and the second one is used to power the op-amps and give plus minus 10 volts. To display the waveforms, we have used a digital real-time oscilloscope. As you can see, the channel 1 is showing the input sine wave and the channel 2 is showing the output of the low-pass filter. Initially, the function generator is set to 100 Hz. The output voltage at this frequency is equal to 1.56 volts. Now, as the frequency goes on increasing, the output voltage goes on decreasing. At a frequency of 113 Hz, we find that the output voltage is 1.4 volts, which is 0.707 times the input voltage. This implies that frequency of 113 Hz is the cutoff frequency for this filter. Now, as the input frequency is further increased, the output voltage falls in the millivolts range. At a frequency of 200 Hz, the output voltage falls to 640 millivolts. And as the frequency is further increased, the output voltage goes on decreasing, which is consistent with the property of low pass filter. The high frequency components are not passed. Similarly, we implemented the circuit for control voltages 1 volts and 8 volts and found out that as the control voltage is increased, the cutoff frequency also increases and thus the bandwidth of the filter increases. The main advantage of using Taub-Thomas bi-quad filter is that different filter functions are achievable by just adding passive components to the circuit. The analog starter kit is more focused on the system design rather than circuit design. Thus, it's a very versatile board wherein large number of circuits can be implemented on a single kit. The major challenges that we faced while designing the circuit were, first of all, we were finding it difficult to get familiarized with the circuit connections and to relate it with the actual problem statement circuit given. The second difficulty was to take the readings of the phase difference between the input and the output voltages for very high values of frequency.